In this video, we'll see the solutions of linear system. We'll check for the existence of the solution and uniqueness of the solution. That means whether the solution exists or not, and if it exists, is it unique or not. And we can do all this using the concept of rank, which we have discussed in the last topic. So, solution of linear system. So we'll check for the uniqueness and existence. Of course, we'll check for the existence first, then uniqueness, right? So we were seeing the system of linear equation ax is equal to b, right? We were seeing this system of linear equations. Let's see the case 1. If b is equal to 0, the system of linear equation becomes homogeneous system of linear equations, let's say, right? And in this case, there will always be one solution possible, at least one possible. Like, for example, if I say ax plus by equal to 0 and cx plus dy equal to 0, these are two straight lines, right? And if these two are straight lines and they are homogeneous also because the coefficients are 0. Now you can see that both the lines are passing through the origin for the xy plane. So there are, no matter what a, b and c, d are, like it can be 2, 3, 4, 5, 6, 7, anything, it will still have one solution for sure, that is the origin x equal to 0 and y equal to 0. And then they may have many solutions, that will happen when they'll coincide, they'll coincide, right? So the homogeneous equation will always have one, or I'll say at least one solution, and the solution is x is equal to 0, 0, so on, all the elements to be 0. So this is known to be your trivial solution. This is always there, right? Now there's no question on being existence of the solution. There's no question on being consistent. If the solution exists, if there is existence, we call it consistent. Otherwise we name it inconsistent. So if the solution exists, it is consistent. If it does not exist, it is inconsistent, right? So obviously this homogeneous equation comes under consistent set. And out of this, whether it will have one solution or more than one solution, that we have to see. So if rank of A is equal to n being the number of unknowns, if rank of A is equal to n, then it will have unique solution or one solution. And if rank of A is less than n, then it may have infinite solution or many solutions, right? You can also say if the number of equations is less than number of unknowns, then it will have rank less than n. Just imagine the number of unknowns are 2 in this case. What if we have only one equation, ax plus by equal to 0? We don't have the second equation. Then we can say there are infinite number of solutions. So there is one more point to be noted in this. That is, you can make a note. If the number of equations is less than number of unknowns, then it will have many solutions. Right? Why so? Because the rank is going to be less than n, and we have seen if the rank is less than n, it will have infinite solutions. The second case is like this was first case, homogeneous equation. The second case is when B is not null. That means it can have at least one of the element to be non-zero. So this will give you non-homogeneous system of linear equations, right? So in that case we'll check for the consistency and inconsistency. So consistent, that means the solution exists, comes when the rank of A and rank of A augmented B are same. Now we know what is A augmented B. For the AX plus AX equal to B, we'll have A and we'll have A augmented B, and if both the ranks are same, we are expecting at least one solution. And out of this we'll have two conditions. If rank of A is equal to rank of A augmented B is equal to n, n is the number of unknowns, then it has unique solution, that is one solution, right? One solution. And if rank of A is equal to rank of A augmented B, which is less than n, then it has many solution or infinite solution. It will have many solutions or infinite solution, right? And what about the inconsistent case? Inconsistent, that is no solution, and this will happen if rank of A is not equal to rank of A augmented B. So if we don't have the rank same, we are not going to have any solution, right? So in that case, no solution exists.